All right, this might blow your mind away. Comes out of the remainder theorem. And I'm not going to get into how that theorem was developed. You can Google that, and I'm sure you can find a fascinating lecture on exactly how that came about. But what it tells us that if I have some polynomial function f of x, and I divide it by x minus c, then the remainder is going to be f of c. Well, that certainly clears it up there, Willie. What in the world just happened? Yeah, I know. So let's look at an example and kind of get a sense of what's happening. And maybe you can go, oh. So I have some polynomial function, f of x. It equals x cubed minus 4x squared plus 5x plus 3. I want to divide it by x minus 2. So let's do that. Long division, synthetic. Synthetic? Okay, that's what I'm hoping you what you said. So this becomes 2. The coefficients, descending order, are 1 minus a 4 plus a 5 plus a 3. Synthetic division works by dropping down the 1. 2 times 1 is a 2. Add those. Negative 2. 2 times negative 2 is a negative 4. It's so easy, I have to be careful. I might make a step or a mistake just because how easy it is. Becomes a 1. 2 times 1 is a 2. And I have a 5 left over. Now remember, this term, that was our remainder. And I won't put these back into terms, but I just want to pay attention to what that number is right there. So if I divide this polynomial by x minus 2, I get a remainder of 5. Well, this remainder theorem tells me that if I evaluate this function at 2, so f of 2, evaluate it at 2, so this becomes 2 cubed minus 4 times 2 squared plus 5 times the 2 plus a 3, 8. Minus 4 times 4 is 16, plus 10, plus a 3. Let's add all those up. This gives me a negative 8, plus a 10, which is a 2, 2 plus a 3, which equals 5. Are you kidding me? F of 2 equals 5? When I divided this polynomial by x minus 2, I had a remainder of 5? What's going on here? So I can evaluate a function by using its remainder to tell me what its value is? Wow. And that's even more of a wow that when we have to start to evaluate very large functions where the numbers just are hard to manipulate, that I might be able to use synthetic division and look at its remainder. And that's where I'm going to find its value rather than computing it through substitution. Oh, I know, I don't think you quite have a grasp of what we just did there. But with practice, I hope that you start to see, like, okay, this is something cool.